And good afternoon. Welcome to our webinar, Introduction to CT Phantoms and Some Other Differences. My name is Tom Douglas. I am our sales manager in the Americas, and we'll be walking us through today a few housekeeping items. First of all, thanks for joining us on StreamYard, and if you're watching this on LinkedIn Live, we appreciate it. This will be recorded, so will be available to you at a later time. Once we do, we'll get it posted up to our YouTube channel. The address is there. And there you can find other videos, help videos, other webinars that we've had. Other thing is there is a comment section if you're joining us on StreamYard. So if you have questions, comments, etc., feel free to put those in at any time. Try to address questions when we get closer to the end. But feel free to use that or chat amongst yourselves. So what are we going to talk about today? Just briefly, probably a lot of you familiar already with CT technology, but just walk through it real briefly. Highlight a few of the standards, regulations, more recommendations really for CT quality assurance. And then we're really going to look at a number of the more popular CT Phantoms, not just the ones we make, but some from other manufacturers as well. And then look at like some of the differences. So if you're trying to determine, hey, what's going to be the best fit for us, maybe some things to take into consideration when helping to make that decision. So just briefly about us, you're probably familiar with Diagnomatic by Pro Project, but we're a manufacturer of diagnostic imaging phantoms and test objects, and we also make a web-based software solution that can help automate your quality control program for diagnostic medical imaging equipment. So we're kind of an all-in-one shop for quality assurance. So let's talk a little bit about how CT works. Here we got a image here, a little CT machine, probably looks familiar. And it works by combining X-ray technology with computer processing and create a detailed cross-sectional image of the body. So the CT scanner consists of a circular opening with an X-ray source. It rotates around the patient. As the patient lies on a motorized table that moves through the opening, the X-ray source emits a narrow fan-shaped beam of X-rays, and these X-rays pass through the body and are detected by detectors on the opposite side of the circular opening. So then the X-ray source rotates around the body, typically completing one rotation in about 1 second. During this rotation, the machine takes multiple snapshots or projections of different angles. The thickness of the X-ray beam can vary from millimeter up to a few centimeters, depending on the desired level of detail. Then we do a little image reconstruction. The data collected from these multiple projections are sent to a computer, which uses complex algorithms to construct the information to cross-section images or slices of the body. And these slices can be as thin as half a millimeter, providing highly detailed views of internal structures. Many modern CTs are using a technique called spiral or helical scanning. In this method, the table moves continuously through the scanner while the X-ray source rotates, creating a spiral pattern to collect for data collection. And this allows for faster scanning and the ability to create three-dimensional images. In some cases, contrast medium is injected into the patient's bloodstream or given orally to help enhance visibility of certain structures or blood vessels, and differentiate between various types of tissues and abnormalities easier. Once the scan is complete, the images are processed and can be viewed on a computer screen. Radiologists can manipulate these images, adjusting contrast, brightness, viewing angles and get the most informative view of the area of interest. CT scans typically take less than 15 minutes to complete, with most of the time really being spent on preparation. Technology continues to advance, and some of the newer systems capable of imaging multiple energies simultaneously and help produce increasing detailed images less time. Now, regarding standards and guidelines, there's multiple ones out there. Being the states, two that people look at the most. ACR is always a driving force in the U.S., and a lot of other countries look at it as well as a good benchmark. Also look just briefly here at the Task Group 66 from AAPM. They also have some recommendations, but for ACR, quality control program has to be established and implemented under the supervision of a qualified medical physicist, and facilities have to maintain documents, QC programs, and comply with minimum testing, whether it's daily, monthly, yearly, or the annual notifications. And then Task Group 66 is a quality assurance program for CT simulators and CT simulations for radiation therapy. It standardizes QA practices across all radiation oncology departments and help to improve the quality and safety of CT simulation processes. There's currently an update to TG66, the U1, looking to upgrade the original. So that's always or currently is ongoing. So we'll go a little deeper at the ACR accreditation. For annual QA, it has to be tested annually. It has to perform all these certain tests. So prescription alignment accuracy, table travel accuracy, radiation beam width, low contrast performance, spatial resolution, CT number, uniformity, artifact, symmetry. And there's a number of tests that are required daily and monthly as well. As far as record keeping and documentation, really good resource, acraccreditation.org page that has links and PDFs of every modality that falls under the ACR accreditation program, but also gives you all your paperwork for, again, the record keeping side as well as test taking techniques. So it's a really good resource. Even point you in the right direction of where to buy a ACR accredited Phantom. The AAPM Task Group 66 is a little bit different again because it's focused more on the radiation oncology departments. But here they have a number of mechanical tests required for laser alignment, table movement, table indexing, accuracy of both of those. Still have that image quality test for testing the CT number accuracy, uniformity, high contrast spatial resolution, low contrast, detectability, image noise. There's dose tests. AAPM's been putting more focus as of late into measuring dose and offering more flexibility in how dose is measured. Always looking for better ways to do that. CT simulation, specific tests, so virtual simulation software accuracy, image transfer, geometric accuracy, and a few other tests they recommend as well as scan localization, table attenuation, and then gantry tilt accuracy. So now let's move on to the Phantoms that we'll be talking about. As far as CT Phantoms, the three we'll be looking at here, the Gammax 464, which is probably the most well-known CT Phantom, probably followed closely by the CAT Fan. CAT Fan's got a number of options. We're going to look just a little more closely just at the 600 today. A few comments about the 500, 700, and they've got some variations of that. Then we'll also look at the Diagnomatic, our Pro CT Mark II, and then look at a few of the different electron density Phantoms, with the standard one, but then also the advanced density Phantom, the dual energy Phantom, and then also look at the CTDI Phantoms as well. So first, as mentioned, is the Gammax 464 offered by Suducular and Mirion. And it's currently the only Phantom authorized to be used part of the ACR CT accreditation program, and has been for for quite a while. It'd be nice if ACR opened it up. We asked that question of them, hey, would they consider another manufacturer? So we'll see where that goes. But it also supports all the image quality tests recommended by the Task Group 66 as well. So this again tends to be most popular Phantom out there used in CT. How it's made up, I guess from a Phantom standpoint, we say relatively simple, but really the design hasn't changed, and I think it's been over 20 years, possibly longer, I believe this time. It's made up of 4 slices, 20 centimeters in diameter, 4 centimeters thick. First is testing for CT number accuracy, slice width. Second, low contrast resolution. Third is for image uniformity and noise, and fourth, just the high contrast resolution. So looking a little deeper here, these 4 modules. So module 1 is used to assess the positioning alignment, as we said, CT accuracy number, slice thickening, or thickness rather. The background material is water equivalent for positioning. The module has a 1 millimeter steel BBs, or has BBs embedded. The longitudinal add to the center of the module and to the outer surfaces of the BB at the Phantom surface. They're at 3, 6, 9, and 12 o'clock positions. So to assess the CT number accuracy, there's cylinders of different materials. There's a bone mimicking material, polyethylene, water equivalent material, acrylic, and air. Each cylinder, except for the water cylinder, has a diameter 25 millimeters and depth 4 centimeters. And then to assess wire image width, there's 2 ramps are included that consist of a series of wires that are visible at 0.5 millimeter at the z-axis increments. Module 2 is used to assess low contrast resolution. This module consists of a series of cylinders of different diameters, all at 0.6% or 6 Hounsfield units. The difference from a background material having a mean CT number approximately 90 Hounsfield units. The cylinder background contrast is NEG independent. There are 4 cylinders for each of the following at 2 millimeters, 3, 4, 5, and 6. And then the space between the cylinder is equal to the diameter of the cylinder. 25 millimeter cylinder is included to verify a cylinder to background noise or contrast level and to assess contrast to noise ratio. Module 3 consists of a uniform tissue equivalent material, CT number uniformity. 2 very small BBs are included for optional use and assessing the accuracy of the implant distance measurements, used to assess the cross-section sensitivity profiles. Then finally, module 4 is used to assess high contrast spatial resolution. Contains 8 bar resolution patterns, 4, 5, 6, 7, 8, 9, 10, and 12 line pairs per centimeter, and then each fitting into a 15 by 15 millimeter square region. There's also a aluminum bar pattern, provides high contrast relative to the background material, and there's also 4 1 millimeter steel beads, and similar to the module 1. There's a little bit of a technical breakdown of it. So moving on to the CAT fan. Again, CAT fan is certainly one of the better known fans for CT as well. The 600 is made up of 5 different slices or modules. And first is checking slice width, pixel size, different color for Teflon, the acrylic, the polyester, the water, polyethylene, the PMP and air, slice geometry and point source bead, high resolution, low contrast, and image uniformity. So these are doing a few more. It'll do a little bit more than the Gamex. Again, checking for that CT number accuracy, spatial resolution using the modulation transfer function, low contrast resolution, noise, uniformity, slice thickness, and pixel size. So if we're looking at major differences between the 464 and the CatFan 600, obviously the first being that the 464 is designed specifically for ACR accreditation. So you can only use that Phantom if you're applying for ACR accreditation at your facility. On the other hand, with CatFan, it's much more versatile for QA for conventional CT, but then also for cone beam CT systems as well. And it tends to be more commonly used for testing and commissioning of CBCT systems. And it offers a wider variety of tests. A couple examples: the pixel size verification, and then a few more materials under CT linearity. So that moves on to the Pro CT Mark II. Similar to the CatFan, we have various modules. Standards, there's 5 inserts: the low contrast insert, a CT number linearity, geometry, resolution, and the homogeneity phantom, which is a water-filled phantom instead of a solid. We do have the option; we can do a solid water insert as well. As seen here, you see this kind of similarly with the CatFan as far as positioning. You can use the case as a counterbalance for setting up the phantom. We do also have racks for GE, Siemens, and Canon, so that makes setup a little bit easier and a little bit quicker. Helpful tool. But looking at the individual slices for the CT Mark II, first being the low contrast module, which helps evaluate the number of distinguishable low contrast objects, and then points out that the reference value of these should be evaluated by performing a series of measurements for a completed function CT scanner right after the installation, and should be repeated anytime there's a modification or repairs of the device. And then includes a number of diameter rods at 1, 2, 3, 4, 5, 7, 9, 11, 13, and 15 millimeters, and gives our percentages here of what they need to be at least visible and best visible. High contrast module includes a number of distinguishable high contrast objects and should not differ from the reference value. Also does the modular transfer function. I guess backing up briefly, the MTF, and you may know this already, it's basically a measure of how effectively an image system transfers the spatial frequency content of an object into the final image. It qualifies the system's ability to preserve contrast and spatial resolution across different spatial frequencies. So you see these ranges between 0 and 1, where 1 represents a perfect transfer of contrast and 0 represents no transfer. You can kind of see on the chart here, as the spatial frequency increases, MTF typically decreases and indicates a loss of contrast to finer detail. And MTF's considered the most widely accepted measure of spatial resolution response in X-ray detectors. So one of the extra tests, we're running an MTF 50 test, which is the spatial resolution when the MTF falls to 50% of its low frequency value. In other words, it's the frequency where the contrast of the images drops to half its original value, and MTF 50 correlates well with perceived image sharpness. The sensiometrics module for CT linearity has a number of different inserts. Again, backing up, the Hounsfield units it's used to help quantify different tissues in a CT scan. So, for example, water has a HU of 0. Fat has HU of somewhere between -100 and -150. Bone has a value of +1,000. So tumors also have characteristics, Hounsfield units, and they can be used to help distinguish them from normal tissues. So looking here, a variety of the different inserts that are standard, and then we also have optional insert, and point that out here shortly, of some of the different materials can be tested as well. The geometry module is measuring distances between 4 rods, the horizontal, vertical, diagonal, and then also has 4 rods with the 5 millimeter diameters, 4 rods, 3 measurements there, and then you can see that cross section with the 2 ramps, and those are slightly different than the ones on the CatFan as well. Point that out here momentarily. And then the last being the homogeneity module. And here's where you have your artifact. You can check the noise, uniformity, and the requirements that are needed on each of those. As I mentioned, the ProCT Mark II is a modular phantom, so we can make different changes to it. Different inserts are available. So first being that electron density insert shown here. So it'll give you some different material beyond what the standard insert would have. Mentioned we have the water equivalent because that tends to be the standard one with the CatFan 600. So we have that as well as an optional. There's one with optional spheres. There's one with a wider range of pattern up to 30 line pairs per centimeter. We have a wave insert beat blocks as well, and then also a beam hardening ring at 2 different oval diameters that are available for it. So again, great thing about modularity is we can change inserts and build a phantom that's going to run the tests that you want. So just comparing the physical differences, just point this out briefly that we're still looking, both of these has the 5 different inserts, although they're just a little bit different between the pair of them. So digging in a little bit more if you want to, as far as the detail. CatFan obviously is a little bit smaller in diameter. Low contrast inserts levels are roughly the same, except for the one that's, small, very small difference. Rod sets are roughly the same. While the CatFan has a combined geometry and sensiometry insert, the ones we build, we have 2 separate ones. They have a standard B geometry insert, so it's a little bit different. We do have one, it's just an optional insert. The Mark II solid water is standard, whereas ours is fillable with we use the distilled water, but we do have that solid water as an option. So if that's important, we can absolutely do that as well. And probably the one other larger physical difference is the geometry, the ramp angle. It's about 23 degrees for the CatFan, while ours is about 26 degrees, and that ramp angle for the CatFan is flatter relative to the scanning, a little bit easier to measure that visible strip, so a bit of an advantage with the CatFan there. So we had a number of hospitals and colleges in Dublin, Ireland, compare the CatFan 600 and the ProCT Mark II, and they published this study a little over a year ago. And while their main focus was looking for ways to optimize quality assurance testing, they did look at the images of what they were getting with both the CatFan 600 and the ProCT Mark II, and kind of comparing those. Won't read through all of this. I can get the PDF. We can make that available. It's actually posted on our website as well, if you want that study. But long and short is they really found that image-wise they were getting pretty good and similar images between both phantoms. So they're happy with what they got with both. I think one that stood out was we have one less group of the sharp kernels than with the CatFan, but overall the 2 images, or the data they got was very, very similar. So they compare quite well with each other. The one area where they found where we had a little bit of advantage was our software, our Diagnomatic software solution. They found that it's definitely a way to help streamline their QA process. So they liked the automated QA summaries, the trend data analysis, and the ability to recommend future testing dates. So using the software gives you the ability to run all those tests, run all the scans, and then still provide all that planning and trending data that you may not get with other sets of software. So it was some good feedback. Again, if you want to copy that study, it's available on our website. I added this in there too, because this has come up, the CatFan 700. We can test similar to the 700. It just basically requires some different inserts. So we still have that standard Pro CT Mark II. And then if you get these 4 extra modules, you can basically build your own CAD-FAN 700 for probably quite a bit less than CAD-FAN can sell for you. So yeah, there's an optional subslice contrast, optional spheres, and then that wider range of patterns. So resolution model up to the 30 line pairs per centimeter, and then the wave insert and bead blocks. So, and those are even the part numbers are on there as well if you were trying to build something similar. So moving on to the electron density phantoms. These are help to enable precise correlation between CT numbers and electron densities in various tissues, help correct tissue inhomogeneities and radiation therapy treatment planning, and help evaluate CT data scanner, the relationship between CT number and tissue density. Just kind of a breakdown of some of the tissue equivalents that tend to be standard for lung, breast, various bone densities, liver, muscle, proposed tissue, water-filled plug, and also have the ability to do optional titanium and steel rods. There's a number of different manufacturers that have these electron density phantoms out there. They all tend to have similar inserts. We make all these inserts ourselves. Don't outsource that. So that brings us doing the dual energy phantom. This is a little bit larger than the standard electron density phantom. Also allows you to scan at both that 80 kVp as well as at 140. So it gives you a little wider range, helps for more in-depth testing, and tends to have some different rods, calcium, blood, and so this allows for assessment of spectral contrast, dose efficiency, and can vary depending on the DECT technology, the dual source, rapid switching, dual layer detectors. So that brings us to our CTDI phantoms, and that is used to calculate dose, and it's going to measure the absorbed dose. And again, this is another test. It's also helped under the APM task force 66. Here's one set up, both the head and body unit there. So the phantom is positioned, ISO center of the scanner, and pencil chamber, and the rest of the holes on the outside are filled with acrylic rods, and then an axial slice is acquired at the center of the phantom, and then take a measurement from there. Here is the formula that's typically used for measurements of the different values of the different spots or points along the phantom. How that's calculated. So that's it for the phantoms. Touching briefly on the software, for those that are not familiar, our software is a cloud-based solution, and what it allows us to do is take an image of the phantom, pushes that image to a cloud environment that will analyze images and then send it back to within about 5 minutes. So it's a way to speed up the process of analyzing images, not just CT, but other modalities as well, and keep that as a single repository for all of your QA imaging information. Obviously, the Pro CT Mark II is one that we can use with our software, including a lot of the modalities, including radiography, mammography, MR, dental. So a lot of versatility. And basically what it does is just a small application, works in the background, allows you to connect all your imaging devices to a single account. And it really, if within an imaging center, only needs to be installed once in one computer, and then it allows you to send images from, you can send images from any of your devices, choose relevant devices, and choose what you want to push to the cloud. And it does have that ISO certification for cybersecurity, so that helps when working with IT. But that's what we have for today. Again, if there's any questions, comments, comment section's open. Again, we'll make these recordings available. Be available on LinkedIn, YouTube page. Feel free to email me if you come up with questions afterwards. Concerns, try to help you out as best as possible. Email address is tom.douglas@diagnomatic.com. Just to see if anything comes through. Be a little more quiet group today. That's all right. So again, thanks so much for joining us. We'll probably send something out with want to get your input for the next round of webinars that we're going to do, see what topics are going to be most interest or most helpful to you. So thanks so much. Enjoy the rest of your day, and we will talk soon. Bye now.